just click on the option B. Then the next question says, find the range of values of x satisfying the inequalities. So we have 5 plus x less than or equals to 8. So we are going to solve, we have two disparate equations. The second one is 13 plus x greater than or equals to 7. So here we have 5 plus x less than or equals to 8. So let's solve this one. Let's solve them separately. So in this situation we collect like terms. So we have this one goes to the other side. We have x less than or equals to 8 minus 5. So our x will be less than or equals to 3. That's the first one that we solved. Then the second one, 13 plus x greater than or equals to 7. So collect like terms again. So we have x greater than or equals to 7 minus 13. And what is 7 minus 13? 7 minus 13 will be minus 6. So we have minus 6. Now, look at this. Let's place this side by side. X is less than or equals to 3. And that same x is greater than or equals to minus 6. So automatically what it means is that this one can be written as minus 6 less than x. Then if you have to combine it now, it will be minus 6 less than x, and x is also less than or equals to what? So it will be minus 6 less than or equals to x less than or equals to 3. This will be the combination. So we'll go to our option and see the one that matches what we have. So in this situation, it will be no other answer than the B. That's the B option. Minus 6 less than or equals to x less than or equals to 3. That is the B. Then this third question has also solve the quadratic inequality. So we are given this. These two that we have solved now, we have not used graph. So that the third one will test our ability to analyze the use of graph. So in this situation, let's see. We have x squared minus 5x plus 6 is greater than or equals to what? 0. That's what we are given. So in this situation, the first thing we have to do is to solve this quadratically first. So if we have to solve this quadratically, what we need to do is to use this to multiply this. Then we are going to have plus 6x squared. We are going to look for two factors of 6 that the addition of or subtraction will give us the number in the middle. What are the factors of 6? We have 2, 3. Then we have 1, 6 itself. So if you add this up, it will give us 5. If you multiply it will give us 6. But the one that will give us this is minus minus. Minus 2 times minus 3, that's plus 6. Minus 2 minus 3, minus 5. I think this one is suits that. Here, this times this, plus 1 times plus this, that is plus 6. Then we have, the only condition you can have here is plus minus 1 plus 6. That's the only condition you can have here is plus 1 minus 6. That will give us minus 5. And plus 1 times minus 6, that is minus 6. And it's not minus that is here, so it can't be this. Rather, it will be this. Then it will be minus 2x minus 3x. Anywhere we see minus 5x, we replace it with what we have here. So let's go back to our original equation where we have x squared. Instead of writing minus 5x, I'll write minus 2x minus 3x plus 6 greater than or equals to what? 0. So at this point, I can now dissect what I have. So by dissecting this, I now have what is common here? X is common. I bring it out. I'll be left with x minus 2. What is common here? You bring the minus out first. What is common here? 3. 3 is common. Then you left with x minus 2. The content of what you have here must be the same. That is the only way you can convince yourself beyond reasonable doubt that this question has been factorized successfully. So in this situation you have this, then we have x minus 2, x minus 3, greater than or equals to what? 0. Having gotten to this junction, then we resolve into the use of graphical method. So if you have to use graphical method, look at our inequality, quadratic inequality. We discover that the coefficient of our a will be what? 1. So if it's 1, then and 1 is greater than 0, automatically a will be greater than what? 0. That's why you have our curve. That's why we have a minimum curve. Take note of that. Where this is our y-axis, this is our x-axis. The next is to determine the critical points. The critical points can be determined by equating each one of them to 0. So we have x minus 2 equals to 0, which implies that our x equals to what? 2. We have x minus 3 equals to 0, which implies that our x is equals to what? 3. 2 and 3, which one is greater? 3 is greater than 2. That means 2 will come first. So 2 will be at this point, then the 3 will be at this point. And since we have this region to be positive, this region to be negative, this region to be positive, so in that situation, we go to our original equation and see what the whole quadratic expression is, whether it is greater than 0 or less than 0. If it's greater than 0, that means it is positive. So we go to the positive regions and shade the positive regions. So here, what we have is greater than or equals to what? 0. Automatically that's positive. Then we go to our positive region and shade. We shade this region, we also shade this region. And since they are not convergent, that means they will be separate. And I said on your left-hand side region of your vertical axis is going to be less than. I told you the other time. Then the right-hand side of your vertical y will be what? Greater than. So in this situation, I will have x, because I'm dealing with greater than or equals to, it will be x less than or equals to 2, or x greater than or equals to what? 3. So go to our options and pick the one that matches what we have. So in this situation, let's go there and see the one that will correlate with that. X is less than 2, or x is less than or equals to 2, or x is greater than or equals to 3. X is greater than, x is less than or equals to 2, and x is greater than or equals to 3. So that is option A. You can see how I've been able to use analytical and graphical method to fashion out the answer to this very question. So it is not far-fetched. It is very simple, and it is done within the shortest possible time. Look at question 4. There is a trap here. You are given x squared minus 1 greater than 0. So you have to find the value of x that satisfies this inequality. In this situation, if you look at this closely, you discover that they are trying to test a concept that is called difference of two squares. They call it difference of two squares. You have a squared and you also have b squared. Then their difference will be a squared minus b squared, which states that a plus b, a minus b. So that is what the concept of difference of two squares is talking about. In this situation, we know that 1 square is 1. So automatically we can say x squared minus 1 squared without violating the fundamental principle of mathematics, and it still remains the same, because 1 square is what? Is the same thing as 1, and that has not tampered with the what? Original equation. Now the next thing to do is we apply difference of two squares here. So it will definitely be what? X minus 1, x plus 1 is greater than what? 0. So if you look at what we have, when we multiply x by x, we have plus x squared. So what it means, our a is what? Is equals to what? 1. And 1 is greater than 0. Automatically a will be greater than what? 0. So we have the shape of our graph. We have a minimum graph where our y remains the same and our x remains the same. In this situation, we are having this scenario. So the next thing we need to do is to determine what? The critical values. So how do we determine the critical values? Is by equating each one to what? 0. So we have x minus 1 equals to 0. Our x equals to 1. X plus 1 equals to 0. X equals to minus 1. Minus 1 and 1, which one is greater? 1 is greater than minus 1. So minus 1 comes first here, then 1 will be here. And since the one we are talking about is greater than 0, anything that will be greater than 0 will definitely be positive. So this is our positive region, this is our negative region, this is our positive region. So we go to the positive regions and shade. Since our graph is what? Positive. So we shade this. So what are we having here? We are having, I said on this side, left hand side, it is less than, here, greater than, the vertical line, which is your y-axis, the side below that, that's left, less than, y, the one that is above that is what? Greater than. So in that situation, I would now have what? X less than minus 1 or x greater than 1. So this will be the solution that will satisfy that, the values of x that will satisfy the inequality. So let's go to